Now let's consider the following example. This is the quick revision session. Probably you have an exam to write, so very quick revision for you to write your exams. Now let's see, factorize the following completely. The first one is, that is a past question, June 2007, question number 2A. And then we have x squared. So that is the first one. We have x squared plus ax minus x minus a. We are being told to factorize completely. Now here you can see x squared and x. So x is common. So you can factorize x out. So when I factorize x out, what is left? I have x here plus a. Now over here we have negative x, negative a. Clearly negative 1 is common. So let me factorize the negative 1 out. So I'll get negative 1 and here will be x plus a. Now let's see, negative 1 times x, that is negative x. And then negative times positive, that is negative a. So here we can see that x plus a is common. So what do? We factorize the x plus a out. So we have x plus a, which is out. Let's bring our equal to. What is left here? We have x minus 1. And that is all. Now let's see the second question. The second question, we have 3y plus 1 minus 7x minus 21x y. Now let's see, here we have 3y plus 1. Now let's see if we can get the same 3y plus 1 over here. Clearly 7x is common. Factorize 7x out and then we can get our 3. Okay, so from here let's bring our equal to. We have 3y plus 1. Probably when we take out 1, now here we can take out negative 7x out. And what do we left here? We have 1. Because the negative 7 is out, here you get plus 3y. Now, addition is commutative. So 1 plus 3y is the same as 3y plus 1. So we can rewrite this as 1, that is 1 plus 3y minus 7x, we have 1 plus 3y. So 1 plus 3y is common. We can bring the 1 plus 3y out. So 1 plus 3y out. And what do you have? 1 minus 7x. Now, let's see, we have the third question. The third question, we have bx minus ax plus x squared minus ab. Now, let's assume we are taking this first two, x is common. But then over here, we don't have any common factor. So let's take bx and negative. Okay, let's take bx and then x square. If we take bx and then x square, oh, okay, we can have our b and then 1. Okay, so we can take that. So we have bx plus x square. Now what is left here? We have negative ax minus ab. Now the first two, what is common? X is common. So we can factorize x out. And what is left? B plus x. Now these two, what is common? Negative a is common. So we can bring negative a out. What do you have? X plus b. Now note that addition is commutative. So b plus x is the same as what? X plus b. Why? 1 plus 2 is the same as 2 plus 1. So here let me rewrite it so that it will look the same. X plus b minus a. X plus b. So x plus b is common. Let me bring that one out. So you have x plus b out. Now what is left? We have x minus a. Now let's see the fourth question. With our fourth question, we have 2xy minus 6mn minus 3my plus 4nx. And this is July 2003, question number 3b. Now, when you take this first two, there's nothing that is common. So we can take 2xy and then 4nx. So let's take 2xy plus 4nx. Now let's see, we have negative 6mn minus 3 y. 2x, we can also get 2x over here. So 2x is common, so we have 2x, and then we have y plus 2n. Now let's see here what is common. Clearly 3m is common, it's a common factor, so minus 3m, and here we get 2n plus y. Now note that y plus 2n is the same as 2n plus y. So let's rewrite the first one to look like the second one. So we have 2n plus y minus 3m, 2n plus y. So 2n plus y common. Let's bring the 2n plus y out. What is left? We have 2n minus 3m. Now let's consider the fifth one. That is what I said 2019. So we have 4b squared minus ab plus a plus 9b all square minus a squared. Now here, let us expand this a plus 9b all square. So this will give us, that is 4b squared minus ab. Now when we expand this, we are going to get a squared plus 2a, and then we have our 9b plus 9b all square minus a square. Now from here, this will give us, that is 4b square minus ab plus a square plus, that is 18ab, because 2 times 9, that's 18, a times b, that's ab, and then plus 81b square minus a square, because if you have ab all to the power n, a and b, and hence 9b all squared becomes 9 square b square. Now what can we say? This and that will cancel out, and then we have negative ab and this 18ab. So here, grouping times we have 4b square plus 81b square. That's 4b square, 2b square. That's what we have over here. And then we have negative ab plus 18ab. Now 4 plus 81, that will be 85. So you have 85b squared. Now negative ab plus 18ab, and this will give us 17ab. Clearly 17 is a factor of the 2 terms, and then b is also a factor. So 17b, we can factorize 17b out. Now 17 times 4 will give us 85, 17 times 5. So we have 5b plus a. That is very, very trivial. If you've not subscribed, please make sure that you inform your friends about this page. And can you see the books on the screen? Make sure you get a copy for yourself. Now let's consider the following example. Factorize the following completely. The first one is July 2006, question number 2a. We should factorize. So we have 6x squared minus 5x minus 6. So it suffices us to multiply. That is 6 times negative 36. That will be, no, that is, it suffices us to multiply. That is 6 times negative 6. That will be negative 36. So 2 numbers when you multiply, we get negative 36. But when you add, we get negative 5. That will be negative 9 and positive 4. So we have 6x squared minus 9x plus 4x minus 6. Now, what is common? 3x is common. So 3x out. What do you have? 2x minus 3. Now here, what is common? Clearly, 2 is common. So you have 2. What do you have left? 2x minus 3. So you can see 2x minus 3, 2x minus 3. Factorize the 2x minus 3 out. And what do you have? You have 3x plus 2. Now let's see question number 2. That is, we have 35 minus 2b minus b squared. Now let's see. Here the constant term is 35, and then we have negative 1. So 35 times negative 1, that's negative 35. But when you add, we are going to get negative 2. And this is negative 7, positive 5. So we have 35 minus 7b plus 5b minus b squared. Now this 2, what is common? Clearly 7 is common, so 7 out, we have 5 minus b. And this one, clearly b is common, so we have 5 minus b. What can we see? 5 minus b, 5 minus b common. Let's bring the 5 minus b out. So you have 5 minus b. And what do you have? 7 plus b. Yeah, and that's that. Now let's see the third question. The third question is also a past question of deck 2010, question number 2a. So the question is x squared plus 4x plus 3 plus mx plus 3m. So from here all the way to here, that is quadratic expression, so we can factorize two numbers multiplying, giving us 3. When we add, will give us 4. That is 3 and 1. So this is just x squared plus 3x plus x plus 3 plus mx plus 3m. Now what is common? Taking 2, clearly x is common, so we have x plus 3, we have 1 x plus 3. And then this, what is common? M is common. So when you factorize m out, what do you have? X plus 3, because m is out. So you can see x plus 3, x plus 3, x plus 3 being a common factor. Let's bring the x plus 3 out. So we have x plus 3 out. And what do you have here? X plus 1 plus m. Now let's see our fourth question. Our fourth question we have, that is x squared plus x squared y plus 3x minus 10y plus 3xy minus 10. Now x squared, clearly we can bring x, so let's rearrange. You have x squared plus x squared y. Now you have 3x here, you have 3xy, so let's bring them together. That is plus 3x plus 3xy, and then you have minus 10y minus 10. Now the first one, what is common? Clearly x squared is common, so you have 1 plus y. The second one too, what is common? Clearly 3x is common, so you have 1 plus y. Now this one to negative 10 is common, so you have negative 10, you have y plus 1. But note that 1 plus y is the same as y plus 1. So if you want to rearrange it so that it will look the same thing, so x squared, I can write y plus 1, 3xy plus 1 minus 10y plus 1. Why? Look at it, 1 plus y is the same as y plus 1. Y addition is commutative. That is 1 plus 2 is the same as 2 plus 1. So over here we can see that clearly x, we can see that here y plus 1, y plus 1, y plus 1 is common. So let's bring the y plus 1 out, which is common. What is left here? We can see that we have x squared, what do you have here? Plus 3x. And then what do you have here? We have negative 10x. Now, so you have y plus 1. Now, what do you have here? This is a quadratic expression, and we can factorize this. Two numbers only multiply, you get negative 10. When you add, you are going to get, that is positive 3. That is positive 5, negative 2. So this will give us y plus 1. Then we have x squared plus 5x minus 3x minus 10. Now that is 2. So 5 and 2. Okay, so here we have y plus 1. Now clearly x is common, so we have x plus 5. This negative 2 is common, x plus 5. Now x plus 5 is common, we will bring the x plus 5 out. So you have y plus 1. Then we have x plus 5. Common 1. What is left here? X minus 2. That is very, very trivial. Now let's see the fifth question. We have x to the power 3 minus 5 x squared y plus 6 xy squared. Now with this, what is common? Clearly x is a common factor throughout. So when you bring x out, you're going to get x squared here minus 5xy plus 6y squared. Now, what is in the middle here is quadratic equation in two variables. Quadratic equation in two variables. So two numbers, when you multiply, you get 6. When you add, you get negative 5. That is negative 2 and then negative 3. So you have x squared, that is just x. You have x squared minus, that is 3xy minus 2xy plus 6y squared. So we have x here. What is common here? We have x minus 3y. We have minus 2y. We have x minus 3y. So we have x minus 3y common, x minus 3y. Then we have x minus 2y. Now let's consider the following example. Factorize the following completely. So our first one, we have m squared n minus 16 n to the power 5. Clearly, you can see that n is a factor of the first term, n is also a factor of the second term. So here we can factorize n out, and you have m squared minus 16n to the power 4. Wow. Clearly, I can see that I can make everything over here all to the power 2 and get difference of 2 squares. So let me work towards that. Now 4 to the power 2 will give us 16. So we have m squared minus 4 squared, because 4 squared will give us 16. Now what do we have here? We have n to the power 4, and we can rewrite n to the power 4 as n to the power 2 all to the power 2. Now we know that indices, with this one, we know indices says that if you have a to the power m all to the power n, this is a m n. Hence, if you have n to the power 4, we can write as n to the power 2 all to the power 2, so that 2 times 2 will give us the 4 over here. Now, and then also if we have ab all to the power n, this is a n b n. Hence, we can rewrite this as that is m squared minus 4 n squared all to the power 2. That is from this result. And this is difference of 2 squares. And it says that if you have a squared minus b squared, the difference of 2 squares. This is just a minus b, a plus b. Hence, in essence, this will just be that these are a and then this is b. So we have n here, m minus 4n squared, and then we have m plus 4n squared. Now let's see the second question, question 2. That is x plus y minus 1 all squared minus, we have x minus y plus 1 all squared. Now clearly from this, that's difference of 2 squares. And this is the same thing, difference of 2 squares. So our a is x plus y minus 1. Then our b is x minus y plus 1. So difference of 2 squares. This is just x plus y minus 1 minus we have x minus y plus 1. So a minus b, and then we have a plus b plus the b, which is x minus y plus 1. Now I brought bracket here because the negative is affecting everything inside. So a minus b, a plus b. And this is just, we have x plus y minus 1, and you're going to get negative x plus y minus 1. Negative and negative is giving us positive. Negative and positive, that's negative. And this is just x plus y minus 1 plus x minus y plus 1. Now let's group them from here. Now, x minus x, that will cancel out. And then y plus y, and this is giving me 2y. Negative 1 minus 1, that is negative 2. Now let's see here. Now x plus x, this is giving us 2x. Now let's see, y minus y, that is 0. Negative 1 plus 1, that is 0. we have been told to factorize. Now we can factorize 2 out from here. So we have 2y minus 1. And then we have 2x times 2x. Now this 2 times 2 here will give us, so we have 4x outside y minus 1. Okay, now let's consider the third question. The third question is 9a squared minus 4 into bracket a minus b all squared. This is NOVDEC 2012, question number 2a. So question number 3, that is 9a squared minus 4a minus b all squared. And clearly here we can see difference of 2 squares in this. Now let's change this. We can write this as 3 square a square. And then we can write 4 as 2 square a minus b all square. Now we know from indices, if you have a, b all to the power n, this is a n, b n. Oh no, okay, well, okay. On your channel. Now we know from a, b all to the power n, this is a, n, b, n. So if you have a, n, b, n, we can rewrite it as a, b all to the power n. Hence, over here, we can write this as 3a all square minus, now we have to square here, and this is multiplying this. So we can write this as 2a minus b all square. And this is difference of 2 squares. That is, if you have a square minus b square, this is just a minus b, a plus b. Hence, this one is just 3a minus 2a minus b. That's the first term, a minus b, and then a plus b. That is 3a plus 2a minus b. Now, we have 3a. Now, let's expand here using the distributive property. Negative 2a plus 2b. Negative and negative, that is positive. We bring our bracket, then we have 3a plus 2a minus 2b. Now here, what is 3a minus 2a? And this is just a. So you have a plus 2b. Now 3a plus 2a, and this is just 5a minus 2b. Now let's look at question number 4. Question number 4, we have m squared minus 2mn plus n squared minus 9r squared. And this is NOVDEC 2014, question number 1a. Now from here all the way to this side, this is just quadratic expression in 2 variables. That's from this side to that side. So 2 numbers, when you multiply, you get negative. That is, we get positive 1. When you multiply, you get positive 1. 2 numbers, when you multiply, you get positive 1. But when you add, we get negative 2. What are they? That's negative 1 and negative 1. So this will give us m squared minus mn minus mn plus n squared minus 9r squared. Now, over here, taking the 2 terms, m is common, so we have m minus n. And this one too, negative n is common, m minus n minus 9r squared. Now what can we see? M minus n is common. Let's factorize m minus n out. Now what is left here? M. What's left here? N minus 9r squared. Let's not forget our equal to's. Now m minus n times m minus n, this is just m minus n all squared minus 9r squared. And here clearly we are getting difference of 2 squares over here. So we can write this as, that is m minus n all squared minus 3r all squared. Difference of 2 squares. And this is just m minus n minus 3r, and then we have m minus n plus 3r. If you have a squared minus b squared, that is a minus b, a plus b. So a minus b, that's what we have here, and then a plus b. That is what we have also here. Now let's consider the 5th question. So we have x squared minus y squared plus 6yz minus 9z squared. Now from here, clearly you have y squared 6yz 9z squared. So clearly this is quadratic expression in two variables. So from here we have x squared. Let's bring negative out so that you can get y squared minus 6yz plus 9z squared. So this gives us x squared minus. Now factorizing this, two numbers when you multiply you get 9, when you add that's negative 6, that's negative 3, negative 3. So you have y squared minus 3y z minus 3y z plus 9z squared. So this we have x squared. Factorizing this, taking the two terms, we have y minus 3z minus 3z. We have y minus 3z. Now we have x squared minus, now let's see, y minus 3z common. Let's bring the y minus 3z out. What is left? We have y minus 3z. And from here, we have x squared minus y minus 3z times y minus 3z. And this is the same as y minus 3z all squared. So from here, we have difference of 2 squared. So this is just a minus b. And then we have a plus b. So that is x plus y minus 3z. So from here, expanding with the negative, that will give you x minus y, later negative positive 3z. And this one is just x plus y minus 3z.